Welcome to Risk Roundup. Across nations, the number of people that gets diagnosed with communicable as well as non-communicable diseases, which requires very complex and costly treatments, hospitalization, and at times rehospitalization, is growing rapidly, and healthcare professionals are still struggling to determine when and how to take any possible preventive action. So, how can we use existing and emerging technologies to give healthcare professionals an ability to effectively apply interventions in a timely manner? It seems that emerging machine learning models could offer a much earlier prediction of which patients will develop which specific disease and thereby create effective intervention methods to help prevent onset of disease, hospitalization, or rehospitalization. To discuss one such machine learning model that is based on insurance data to predict hospitalization further, I am delighted to welcome Dr. Vaughn to Risk Roundup. Dr. Vaughn is the data scientist and author of Elsevier publication, Machine Learning on Insurance Data to Predict Hospitalization. He's based in the United States. Welcome, Dr. Vaughn. We are honored to have you on Risk Roundup.
Thanks. It's great to be here. It, as you said, is a very important topic as healthcare is becoming front and center of what we do and what we focus on.
Yes, that is absolutely very true. And we see that across nations, healthcare has become so very expensive. In United States, in our nation, if we talk about, we spend almost 20% of GDP on healthcare, and most developed and developing nations also face rising cost pressures from healthcare spending. There are reports that much of this healthcare expenditure is inefficient, redundant, and waste. And as we see, mobile applications, wearable sensors, electronic health records, and predictive analytics are now generally accepted, commonly accepted everywhere. So since technology platforms, networks, machine learning, and artificial intelligence have enormous potential to solve problems that have overwhelmed the healthcare industry for so many decades, how do you see the transformation happening in the coming years?
We're in a very interesting era of technology and its application, because on one hand, we see, if you look at Google or Facebook or Amazon or Apple, machine learning already right now makes a big difference in what they do, whether it's IDing faces, whether it's giving you predictions on what you're about to purchase in the future and what you might need if it's Amazon, and what you're likely, the route you're going to take to work. For Apple Maps every morning, it tells you, 12 minutes. How did it know it? Simple, pretty simple machine learning algorithms. And so they're actually being implemented in the real world right now. That is not happening at all with medicine. You might see machine learning on some diagnostic tools that measure blood pressure or measure your brain waves, but that type of thing is a rare occurrence, and it's not about the future. It's really about what's happening in that particular moment. So using machine learning to make predictive medicine happen is completely non-existent from the healthcare system right now in any significant amount.
Yes.
So exactly. So, as we can see from these other technologies, there's massive potential here. So what's the disconnect? How come we know it's useful on one hand, and yet it's not being implemented on the other hand? The reason, I believe, is that there's a lot more sensitivity and division of the data itself. So to do machine learning, you got to have all the data in one spot in a digestible format. And right now you see that, at least in the American healthcare system, you have some results in labs, you have some results with doctors, you have some results at hospitals, you have some results with your old insurance company. So your data is segmented and fragmented across a whole bunch of different varieties. And not only is it not all accessible, but it doesn't all talk to each other because there's not a common format. So that's one reason. Another reason that, might be a good reason to have red tape is that it's sensitive data. It's your health, it's your health care. Should everybody have the right to look at all of your tests? Like, should researchers have the right to look at your tests? We're probably doing a good thing, but who knows what we might find out and what algorithms. Maybe you should have to opt in, and we shouldn't just get to scrape the data. So it's hard. This is sort of just phrasing. Why are we doing medicine the way we did it 100 years ago? Which is when you get sick, you go in and doctors try and do something to get it from getting worse or to resolve the problem that you have. Wouldn't an ideal medical system use data to predict that you're likely to get sick in the future and then head it off before it even happens? It's like when you're driving your car and the gas light goes off before you run out of gas. It tells you, hey, you need to do something about it before we have a problem. That's what we want to have. So this paper that we just put out is on the forefront of doing this. It's a very good fortune of teaming up with Anthem, the insurance company, and they gave us a little bit of their data to try and see if we could do any modeling with it. And what's so interesting about this is, as an insurance company, Anthem doesn't have biological data in the sense that it doesn't tell you if you got a CAT scan and what the diagnosis was. It doesn't tell you the volume of platelets in your blood. It doesn't tell you biological things. Instead, it just tells you, was a treatment run? Are you on a particular set of drugs? Because they're paying for it. And what you find is that when you pay for something, people keep very good records. So on one hand, we have a unified set of data. We know everything that's happened in this person's patient history with the insurance company. And on the other hand, the data is impoverished in the sense that it says nothing about whether a CAT scan turned out good or bad, just that you got one. So it was an open question if this would be a useful data system. On one hand, it gets around the fragmented data, but like I said, on the other hand, it's not biological.
Yes.
So
No, go ahead, please. Finish that.
So bringing this to the end, we have this fragmented system that has sensitive data. We teamed up with a healthcare provider, Anthem, in order to unify this data, but on a not as good of a data set as we would want in terms of the features. And then we made this predictive model we predicted two things. One, whether you're likely to go to the hospital the next year. In this particular disease that we looked at, inflammatory bowel disease, about 4 to 5% end up going to the hospital in the following year. And so it's a very costly thing to go to the hospital, both for the insurer in a monetary sense, and for you and me as people. It's obviously a very uncomfortable, unpleasant event to happen in life. So we thought if we could prevent that, it'd be very useful. So we found out that these features do predict well above chance with this model that you're going to go to the hospital or not in the following year. And that's great. It's important to be able to make a prediction like that for the machine learning, but it doesn't really matter unless you can predict well enough such that you can not only predict whether someone's going to go to the hospital, but given the current treatment options available now, if you can actually prevent that with some amount of efficacy and have that be economically reasonable for the insurance company to do. So for example, just because I can predict 55-45 whether something's going to happen, it doesn't really matter unless you can do something about that. You can have a treatment that the cost of that justify whatever predictability you have. So it's a mix of how good your model is with how expensive the different treatments are, and they need to mesh in a way that still makes sense. So we found out that it does. We can actually predict so well, which isn't dramatically well, but we can predict 4 or 5 times what chance is, and that ends up being a predictive power that's not only good for patients because you can tell people what's going to happen, but useful enough where insurance companies could actually bring people preventatively into the clinic and say, hey, in 1 year, it's likely that you're going to go to the hospital because of a flare-up in this particular disease. We want you to get a new treatment ahead of time. We'll switch your medications. We'll run a few extra tests. And maybe we'll be able to actually prevent that hospitalization from materializing in the first place. So bringing it home, the wonderful part about this modeling is not only do you make a prediction, but you can actually treat it and it might never even happen.
Oh, that is excellent. And you made some really interesting points here. The one is the, lack of integration of the data, because you used it. It seems that, the insurance data, But to be able to make accurate predictions, you need much more than insurance data in real time, especially. So typically the primary goal of learning algorithms is to maximize the prediction accuracy or minimize the error rate, so as that we can alert and assist doctors and healthcare professionals in taking further actions to prevent patient hospitalization before they occur whenever possible. And like in your model, as you say, you can predict 1 year before if that patient is going to be developing that disease and would need to be hospitalized. So do you think that we have, I mean, based on your model, it seems like you have taken the first step, but do we have that effective models that would give us the prediction accuracy and interpretability to accurately and efficiently diagnose the whole hospitalization or rehospitalization based on just the insurance data that is available?
Yes. So I'll dig a little deeper in, but there's the short answer, which is this model shows that yes, there's enough predictive power in just the insurance data to make an accurate prediction, and it's not just accurate, it's usefully accurate in the sense that it actually is good enough to justify a probabilistic treatment option, which we assumed you could only prevent this about 10 or 15% of the time. And even if you could only prevent a hospitalization 10 or 15% of the time with people you've identified as being at risk, it still makes monetary sense. And you might say, well, it's insurance data, this is dollars. How would you possibly have any predictive power over that? And we believe that the reason is that on one hand, look, you'd love to have a biological model for how these type of diseases work. On the other hand, with many diseases, including IBD, there's not a really clear understanding of the disease and its progression and all the signals and signs. And so while you can make some sort of estimate, it's not like Huntington's disease or something else where the pathway of disease is very clear. So on another hand, you might say, well, in those cases, what other data are there? And it might be that the human data is what's useful here. When somebody comes in with a particular disease course, the doctors and their years of wisdom put them down some kind of care pathway. You get the X-ray or you get a CT. And if you get a CT, you go on this drug. And if not, you go on this drug. There's a whole, we call it a pattern of care. There's a whole pattern of care that it is happening and is reflected in the insurance claims data. So we believe that while we're not attacking biological data directly, we're attacking the human care pathway. And by zooming out and having this whole picture of all the data at the same time, you can use machine learning to get a much more complete picture of how a care pathway is likely to go for somebody than a doctor might have in a 15-minute visit. They don't have the time to absorb your entire medical history and everything it's done before. And by zooming out, you see all the treatments and tests that have been done, and you can make a much better model of what's going to happen to someone than our limited human brain.
That makes sense. And it seems that there are so many parallel efforts, ongoing efforts on using machine learning to predict hospitalization. So what is the advantage of your algorithmic approach when we compare and evaluate the other models that are being developed?
What other models would you be talking about?
Oh, there are several models that, talk about taking institution-specific approach and developing algorithms based on just the data that they collect within their institution, not just the real-time data, not the data that is, like you are developing based on the insurance data.
Yeah, so if you want to know the exact difference between the models, I would need to know which paper you're talking about.
I mean, what I want to know is that when we evaluate, if we are talking about using this machine learning to predict hospitalization or prevent disease, any communicable, non-communicable, then we want to make sure that the algorithm that we are using that is being developed, that will effectively integrate all the gaps that we initially talked about, but also that it will give us the accurate predictions so that each and every hospital, each and every healthcare professional can use that effectively across nations. So there are a lot of efforts, just like you. There are many doctors, many scientists they're working on developing many different algorithms so that they can predict this accurately. But there are a lot of concerns about using the data set of just the based on the insurance data, because the concern is that these data, it's not real time, and we need real time data, because it's not just the insurance data, but we need also the data of social media analytics, or we also need data about what is the environment in which the individual patient or individual person lives in, and there are a lot of variables in the human ecosystem that plays a role in whether a disease will occur or not, or whether that person will need to be hospitalized or not.
Sure. So without speaking to any model specifically, the questions that you raised are really about.
Yeah, unfortunately, I don't have the details with me right now to give you that. But I read some reviews.
I hear your overall point. So here's the overall answer, which is that you brought up several points. One of them is timescale, and timescale actually only matters depending on if it matters. And so while you say you want it to be real time, it only matters if you're talking about a disease that is affecting you in real time. If you're talking about something like inflammatory bowel disease, where the scale of when the event happens is on the order of months to years, it doesn't need to be real time. It just does. I mean, if you get hospitalized the next year, I don't care if the claim comes in 1 month later. It really doesn't change my model at all. So real time is useful when real time is needed. I agree with that. So I just submitted a paper yesterday so not published yet, but I submitted a paper using machine learning to predict, less about predicting, more about diagnosing right now the difference between pre-anesthetic states and post-anesthetic states. So when someone undergoes anesthesia, how do their brainwaves change? The idea is that you could eventually make a real-time classifier of how deeply someone is in anesthesia. And in that case, you're right, we do want real-time data. So in that case, it matters. And so the algorithms that we develop are real-time and matter for that case. So that's the first point. Things matter when they matter. Another point about mattering when they matter, actually, is that the feature, because healthcare is not standardized and is likely not helpful to be standardized, because there are many different diseases and different doctors at different times think different things are important. There's no consensus on a lot of different diseases. Some of them there are, and some of them there are not. So because there's not a consensus, it's very difficult to make one single model that matches across all hospitals and all diseases, because if you think about in machine learning language, the features do not match, in the sense that just because Anthem says that someone got a CT in the last 2 months, does that map onto somebody else's insurance claim? Well, only if they happen to have bucketed in exactly the same time window of month to month to month, and only if they're talking about the month when it was done and not the month when they received the claim versus the month when they processed the claim. So there's a lot of mismatching of things like that. So I think probably for now the best result actually is, you see this with most new fields, that the best result is actually not to have a single model. It's for everybody to try their best, probably for a couple of years, probably for 5 to 10 years is what it'll shake out. And somebody will have the best general model, and it'll be applied to all sorts of systems. You see that right now with the medical system. You start with Epic, which is one of many different medical systems, and then that gradually gets market dominance, and it generally gets applied to lots of hospitals. Yet at each hospital, it has to be built completely customized. I mean, at every single hospital, you don't just plug and play Epic, the medical record system. You have to customize it for the particular types of departments, fields, and codes that a hospital operates on. So another one. So you asked about timescale. Timescale matters when it matters. 2, the feature, many models versus a few. It's probably going to be many models for a while. And then 3, do I think insurance claim data is the optimal data to put in here? It's probably part of it. Yeah, I think scientists like to get down to it being just give me the biology and I'll tell you how the disease is supposed to play out. But the truth is there's a massively human component, and we're probably not going to capture all the symptoms of the disease in the drugs that we use and when they deliver them. It probably matters what the doctor who spent years of training has decided to do. So the pathway of care and the decisions they make and what order they make them probably is a useful feature that should be included. So if other data sets have that, great. But just biological data by itself I'll just predict right now, will be insufficient for most complicated diseases. And at the same time, this solution might be a temporary one, and then it only lasts for 10 to 20 years until the healthcare system gets itself in order such that we can use better data. But I actually don't care about that. I just care about developing an algorithm that is useful for whatever time it's useful.
Absolutely, absolutely. And you made a very, accurate point that it will have to be based on the disease that you are trying to diagnose. For the disease that you are talking about, bowel syndrome, we probably don't need any more real-time data, because just based on the insurance data you'll be able to predict that. And for many other communicable diseases that are happening across nations, we will have to create other algorithms, because as the synthetic biology advances, and with CRISPR technology is being misused, will likely be misused by some people who are trying to harm some nations. So we will have to come up with accurate way of using algorithms, so that we can effectively, using the IoT sensors and these kind of algorithms, that we can accurately and the social media data and all other data variables that we can get, we can accurately identify when a disease onset is going to happen, so that we can prevent those kind of endemics or pandemics that are coming our way in the coming years. So there are a lot of different variables that we'll have to consider for a lot of different scenarios. But talking about your data set, how did you prepare your data set, and what were the pre-processing steps that you had to take?
Yeah, so I would say I'm probably not the right person to speak to on that. My co-author, Welmud Van Dien, did a lot of the data preparation. I'll give you the overview, which is that insurance data overall is much cleaner than hospital data, because, like I said, it's paid for. And when there's dollars behind something, people keep very good records. So the records are very good. But I think what's tough about insurance claims data, maybe data in general in healthcare, but specifically this, is when let's say someone goes to the hospital. How do I know when they got admitted to the emergency room? Am I sure that they got admitted for IBD, inflammatory bowel disease, or could it have been something related, or something, just pain in the intestines that was from something they ate or from something else? Hard to know. And then even if doctors have conclusively identified one particular thing, did they code it right? Did they give the ICD-9 or ICD-10 codes that were correct for this particular kind of disease? I don't know. I hope so. So a lot of that, what she had to do was go through and figure out, in a system where everything has to fit into some bucket, this bucket or this bucket or this bucket, and she wasn't there to do it. Did people do it right? Was it done differently in different hospitals? Different doctors have different thresholds. Maybe they don't deal with this disease very much in the emergency department, so this is a rare thing. You got, false positives and misses happen all the time for exactly this reason. That the quality of when you get to large scale data across multiple institutions, you end up adding a large set of noise, because the diagnostic criteria at different institutions do differ. And they probably should differ, because it's not a very, very well defined particular biological outcome. It's not extraordinarily clear. So preparing the data was difficult in that sense. That's in preparing the outcomes. Like, okay, what counts as an instance, and which of these people ended up going to the hospital? Those are the patients. And then on the feature side of it, just deciding, feature engineering, when you have not unlimited data, is not the most obvious thing, because you only have one or two passes at it. You have to select all the right features and then train your model and then make the prediction. You can't just select the features, predict, oh, I didn't like that one, re-engineer the features, I do a little better, re-engineer the features, do a little better, because you're overfitting your data. Because you'll just like, if I try 100 models, one of them will perform better, even if it's just noise. So the feature engineering, deciding like, hey, what is a useful feature? Like, if you're on these particular drugs, is it useful what time of year you started? Is it useful how many times in a year you started and stopped these particular treatment drugs? Does it matter which drug you just came from? Maybe there's an interaction effect. Does it matter if you only used it for 10 days and then didn't use it at all? Should that count? Should I have just a binary variable that says, yes, I used it at all this year, or no, I didn't? Should I have a variable that says how many days did I use it? Maybe it's not how many episodes, but how many days continuously or non-continuously that I used a particular drug. Maybe that's predictive. And so you have to make a call on, really, it's like your intuition, because you don't know which ones are going to be useful, because while some models are forward models and you have a reason to predict, most machine learning is what's called a reverse model, which is you have an outcome and you're finding a mix of features that predicts that outcome optimally. But there was a great paper by Halfa and colleagues in 2014 that showed you can actually make zero inference on which of those features actually cause the outcome, other than to say somewhere amongst all the things you found, the signal is there somewhere. But you don't even know if the positives and minuses correspond properly. So you're just making your best guess. So in that sense, feature engineering becomes really kind of an art, not a science. And so that ends up being difficult in preparing the data. Especially, and that's, again, why aren't features uniform across all institutions? So we can have one model because everybody has their better guess.
Yes, very true, very true. So how would you rate your model to lace the industry standard?
It's tough to compare them because nobody has done this is the first case where anyone's ever applied an insurance claims-based model onto inflammatory bowel disease. It's just never been done before. So how does it apply? I mean, it really depends on what you're predicting. If you predict another disease like Huntington's disease, my model performs at 100% probably, maybe 99%, because if you have the Huntington repeats in that particular gene, you're going to get Huntington's disease. There's no uncertainty about it. So if I were to test your DNA, then, so that's the difference both in disease prediction and my feature type, you get 100%. So depending on what you want to call comparable, I think I would probably need more data. If you're talking about predicting inflammatory bowel disease generally in hospitalizations, it's probably slightly better than what's being done out there. And our data uses insurance claims. So,
yes.
And then if you want to say what other, only a few papers have used insurance claims data, period, to predict other diseases. And
yes.
So people have predicted depression outcomes with respect to treatment. And, again, in that one, it's like there's a whole different number of people that respond. And we're talking about responding to treatment, not just getting a hospitalization or not. So sometimes you might measure it by area under the PR curve or area under the ROC curve. And on those, because we have a less prevalent disease, then overall our area under the PR curve is much lower because it's a much rarer thing to happen.
True, very true. Now, but when you use insurance data and when that insurance data is pulled into just one size fit all model, institutional differences in patient populations or how the hospital, handles this disease that you are working on, the bowel syndrome, and the testing and treatment protocols are different in each hospital, and even the way the staff interact, with the health records or insurance data, that is also different. So if, let's say, you talk about Cigna or any insurance company, but they have all the, if you are using Cigna's or any insurance company's record, but they collect the data from so many different institutions, so many different hospitals. So there will be many underlying differences in the data distribution. And how do you mitigate or how do you take that into consideration, the differences and all the different variables that originate from each different hospital, even for the same insurance company?
We don't.
You don't?
Mm-hmm. Yeah, I mean, so that's a source of noise. And most people who do machine learning would say, look, if I measured everything perfectly, I'd get 100% accuracy. So certainly the fact that, as I was sort of alluding to before, that at one hospital I might have this would be my criteria to diagnose you. In this hospital, it's slightly lower. Yep, those are definitely sources of noise that our model does not capture. I think that's probably pretty far down the line.
Okay.
Because it's not only that it's hard to do, it's that I don't know if it's stable enough to be useful to make that prediction. Sure, one hospital might have a slightly lower disease course, but might be because they have a particular doctor there. And then if that doctor's on the shift or off the shift or changes hospital, suddenly that number changes again and my model's outdated. I don't believe that it's long. So our model right now probably captures the average truth across multiple different institutions, which is truthfully what everything does. All predictive models, all science is just true on average. So the question is, I guess, how good of an average is it?
True, very true. So do you see your model serving as an inspiration for other predictive intelligence efforts?
I hope so. I mean, I think it's like we've mentioned. There's not a lot of other cases of people doing it on doing machine learning on claims data in general. Specifically, never on IBD before this paper. But the point I think is it's an inspiration, but the difficulty here is not with inspiring people who do machine learning, because people who do machine learning are typically pretty optimistic about what they could do. You give me the features and I'll make the predictions and everything will look good. The inspiration needs to happen for the insurance companies to realize that now at this point, this is a useful thing for them to start pursuing. It's not a bunch of numbers that, maybe in 5 years will be useful. It looks to be useful right now. And so those are the skeptics and the people who need to be convinced and inspired. And the reason is because I think not only maybe have they been burned in the past on this kind of stuff, like people say they can deliver all these advanced models, and then when you do it on the real data set, you can't. But, there's some cost to this. You have to set up a whole new system of preventative medicine. You don't even teach doctors about preventative medicine at any real level. Like, what do you imagine? You came into your doctor and said, look, I think sometime in the next year I'm going to get hospitalized for IBD. Is there treatment going to, how do you even deal with that as a doctor? You're trained to be a flow chart that recognizes symptoms when they happen, not the possibility of symptoms in the future. Things like that, maybe in mental health there's a little bit, or maybe in family medicine there's a little bit of prevention. But overall, it's besides saying use this and don't use this, there's not a good pathway for it. So insurance companies, to take this on, would have to create a whole department for this. They'd have to create a whole infrastructure to message patients that says, hey, we think you're at risk. You should go into the doctor. And then what do you say? Like, do you charge them more if they don't go in? Do you say, I'm going to pay for the treatment, or do they have to pay for the extra additional cost of going to the doctor? Who pays for it? Do you worry about getting people nervous? Oh my God, I'm 80% likely to go to the hospital next year. What's the right ethical way to mitigate that and not have people unnecessarily worried? Then there's a bias and incentives. For the insurance company, you might be biased to treat people if they show any symptoms. And on the human side, you might say, well, don't tell me if you're not really sure, because I don't want to have that on my mind that I might be sick. And then another final one, which is true with, it's not like, I don't feel bad for insurance companies, but it's maybe an under talked about point, which is that there's this interesting dynamic between the business side of them and the humanitarian aspect of what we do when we're in healthcare. And what, dealing with a person is not like dealing with a good or a thing to make or a thing to fix or a service. It's a very special kind of service that taps into our deep sense of ethics and morality. So let's say that this insurance company implements what we've told them. Should every other insurance company have to do it now? Because they found, should they, just like when a drug becomes effective and it becomes standard of care, all the other insurance companies are now on the hook to provide that. Because, it's standard of care, now you have to pay for it to whatever degree you have to. And so once a drug company or an insurance company develops something that's been successful, suddenly there's a public outcry that it now must be provided to everyone as part of some system. So I'm not disagreeing with that, but I am highlighting the pros and cons of that system, of which all systems have, which is that when you develop something successful, you're kind of then on the hook to continue to provide that and probably expand it to all the other departments. So if you were a self-interested insurance company, which they are, because at least in America, they have a fiduciary responsibility to make money. So we set up this system where we want you to be ethical, yet we hold you responsible for being monetarily responsible only. There's a misalignment of incentives such that I can understand why an insurance company would be hesitant to try something that might be effective and might have to be done across all their healthcare platforms. As much as they might want to say in public, look, we just want to care about our patients, like it's a trade-off for them.
Yes, very true, very true. Now, would you make your algorithm available for others, like other insurance companies or other institutions to review and adapt for their particular use?
Sure, it's online now. It's in the paper. It's in the supplementary material. There's lots of different complicated algorithms you can use for doing machine learning, from a linear regression to, deep neural nets. But we use a simple logistic regression because it's a good baseline to establish a proof of principle. In practice, you'd probably implement something more complicated, but because precisely for this reason, and it's more transparent, you can understand with that particular model how your number of days you've used adalimumab or some crazy particular drug I can't pronounce of these 110 that we have. You can see if that's positively or negatively predictive of a particular outcome, versus when you start to get more advanced into something like a random forest or a deep neural net, the interpretability of the features goes down. And what we find is maybe a bit underappreciated. If you're a machine learning expert, you say, use the best model. If you're a doctor, you say, give me something I can digest and understand. So I think it's important for the two to communicate, to meet in the middle. So we use a model that's very interpretable and clearly understandable by doctors. It's phrased as log odds and odds ratios, which are things that people deal with all the time.
Yes. Let's talk about privacy security, because that would, come up in your efforts or any other scientist effort who are trying to develop machine learning algorithms, because they use the data sets, and the data sets are all about the patient data, and even the insurance data that also has the patient data. So how is the patient privacy enforced, and how do you see the ethics of patient data maintained in the coming years as more and more data sources are used for developing such algorithms?
Sure. It's the same way we do with any of our patient data, which is we just anonymize it. You remove the name, you remove the address or anything if they have it, and you remove emails, you remove any personally identifying information or personal health information that isn't specifically related to the study. So what we get is a huge matrix that one row has all the drugs somebody's used and the times at which they'd use them, but there's no good model for making a backwards inference on who that person is. So in that sense, privacy is protected. It's an important question because, well, obviously it's important because of privacy, but from a methodological standpoint, it's important to consider and think deeply about that question, because while the standard might be to remove name and address and email and things like that, there have been cases in history where those kinds of information have been removed, but because of the kind of data that you look at, you can still understand who the person is. This happened famously when AOL released some of their search data, and you find that people tend to search their own names and search their own zip code, their own area a lot more. You can actually you could pinpoint who it was, even though it was technically anonymized. It wasn't functionally anonymized.
Yes, very true, very true. Now, it seems that using all these existing and emerging technologies, we can solve many problems healthcare is facing today and will likely face in the coming tomorrow. And as healthcare crisis worsens, while technology advances, new tools and new platforms are emerging, rapidly, that will change our traditional, ideas or view about how healthcare should be delivered. So we see that, the whole healthcare is going to go through fundamental transformation in the coming years, but it is not going to happen without challenges. There are, many complex challenges that healthcare, all the scientists or research professionals or, healthcare institutions will face in the coming years because of so many different variables that come into play. So what challenges you think that we will need to overcome to have the transformative effect of AI if we want to, go forward on this journey?
Well, the first challenge is a mental one, and you brought it up, which is the crisis of healthcare. It's so fascinating as human beings, we call it that. We call it a crisis of healthcare, because it certainly seems like that in our current context. But it's not a crisis of healthcare. It's a massive transformational breakthrough and development of healthcare, which is, yes, healthcare costs a lot more, but the truth is you get a hell of a lot more now than you got 40 years ago. So yeah, it might cost more to go to the hospital now, but the death rates have plummeted. And for example, when you go to the hospital, now you get an MRI, and that goes into your bill because it costs more money. But now we can see exactly the location of a stroke or an infarct or any other damage that you've had that normally before we would have to do maybe an X-ray, maybe we'd see it, and we just guess. So while it's a crisis of healthcare, we're really suffering from our own success here, which is that we've decided to pay more money, and we now live much, much longer. during this call, our lifespan went up by probably tens of seconds because our healthcare continues to get better. So we're paying for receiving more treatment. I mean, we could sure design as a society, fine. We don't want to keep pace with the increases in healthcare at all, and our costs would not increase. They would probably go down because we have become more efficient at developing all sorts of things. But now when you go to the hospital, you get a new needle every single time, and you don't reuse the old needle. So that costs money, but the benefit goes up. So I agree that we phrase it as a crisis of healthcare. I just think I would like a mental rephrase of that to understanding that it is a crisis financially, but because it's paying off. So we should celebrate our own successes.
Yes, absolutely.
Yeah, I have a pet peeve about that. I lost track of what was the original question? That was related to that.
Yes, the question was that, how, even I forgot. What did I ask you?
What else are we going to do about the crisis?
Yes. What complex challenges we need to overcome to have the transformative effect of the AI, because there's so much effort is going on, and AI has so much, power that it brings to us, neural networking, and, so much, and there's, big data that we are collecting. There is so much potential in that. So, but it still, comes with complex challenges if we want to, benefit from that. So that was the question, I think.
Yeah, great question. Look, so I think, now that we've rephrased what we're thinking about, I think to that point, we need to have a big success with predictive healthcare that is well publicized, because that will get people on board. And when people get on board, they'll harass their insurance companies, which may or may not make the difference, but they will start to opt in to protocols where you agree to share your data, because people are still very hesitant. They feel like if they share, I had this discussion in my neuro psychology class this quarter. I asked them, would you share all your DNA online if you got it on 23andMe? How do you feel about 23andMe using your data and selling it to partners? And, even in a well-trained group, their particular stance is probably still divided 50-50 on if they were willing to share their DNA, which isn't them. It's just a bunch of building blocks that made them, and it is unique to them unless you're identical twins. So, people, some of it is going to have buy-in from consumers and, patients, I guess we call them in this circumstance, but you're really consuming healthcare and consuming these products. You're going to want you need the buy-in from them that says, I want to share my data. I want to collect data on my Apple Watch and my iPhone about my movement, and I want to put this into some big centralized system. Because we know there's predictive data there. We know there's papers that have come out in the last couple of years that show you can predict the onset of Parkinson's disease before it's been diagnosed clinically, years ahead of time, based on the slight changes in the vocalization patterns that are picked up on microphones on every body if you record, or on your phone if you record it on your phone. So there's clearly predictive data there, but now the question is, okay, are people going to opt in? Probably. Okay, if they opt in, are they willing to aggregate it and share it? Maybe, and that's in one. Okay, and if so, how are you going to merge those features with all of their other healthcare data? Who's going to be responsible for putting it together in the right way and doing the right engineering? And that's a really big task. I don't trust the government to do it well. I might trust Google to do it well. So probably what'll happen is you'll have a couple large competitors that aggregate your data, just like you can pick between Google and Microsoft or whatever to do a lot of your services, or Amazon to do your services online.
Yes. Very
I just wouldn't want the government to do it. There's no way they're going to have the right incentives to do the right feature engineering. And so we're not going to have it. But then as people, we bitch about it because, why isn't it all standardized? It's like, again, it's just a mental thing that we're like, on one hand, I don't want to share all my stuff. I don't trust you to do it right. And on the other hand, how come it doesn't happen? And this is why there's a conflict between these two parties, doing it right and doing it easily. So the buy-in from consumers to share their data, there's going to have to be a way to aggregate it in a meaningful way. Then there's going to have to be a way of who do I give this data, who am I going to share it with? Who's really going to be responsible for making sure all the data is truly anonymized, and my vocalization patterns, if they're really kept in clips and you have to analyze them, how do you know I couldn't eventually template match that to everybody's individual voice? If you have enough people, I know he's in this zip code and this is what he sounds like. That's, Steve Jobs. Maybe we could have identified for him from his vocal clips, or we could have Mark Zuckerberg or whatever. So very difficult question there. So that's why you need to opt in. And then, like I said before, you need the opt-in of insurance companies and people who have the data who want to share it. Hospitals, labs. Right now, the results live with the labs, the interpretations live with the doctors and their notes, and the insurance, and when what actually got done on a big scale lives with insurance companies.
Yes.
And no one's going to agree with the right way to put them together. So it'll probably be imperfect, and there'll be lots of different ways to do it. And there won't be until there's a market for this data where they can sell it. Yeah, that's what's going to happen. I just thought about it, which is that no one's going to change to it unless they can make money off it. So once they can make money off aggregating data in a useful way, then we'll see results. And this is what I do from companies here in Silicon Valley. They collect all this kind of data, and then you bundle it together and slice it and do machine learning, and then you sell it to people as advertisements. And it's not so you can do that well and you make money. Then we take very good care of our data. We're very careful to keep all the features intact and not lose information because there's money on the line. Imagine once there's, one of my co-authors started Your Health, which is a predictive health analytics startup, and it's all about this is the senior author, Daniel Holmes, and he's all about, we found something here. Can we now make a market for it? Can we get insurance companies on board, take the data, deal with it, and then do machine learning and make a prediction? And like most things, academia starts an idea. Now the public sector will take it, and once people want to buy it, the data will be maintained, and people will figure out good ways to do it. So that's a huge part.
Yes, definitely. That's a huge part. But I hope that you focus your efforts on developing an algorithm to be able to, in a timely manner, effectively and accurately predict if someone is, we have this new, whole trend of do it yourself, so you can order genes online, and you can, using CRISPR technology, you can create an entirely new organism, a virus or any pathogen, and you release it in to wipe out some, communities, some ethnicity, or, create a global pandemic, things like that. So I hope that, you or, scientists like you can come up with effective algorithm that can accurately predict. I mean, I'm sure there will need to be an integrated effort. We will need IoT sensors, and we'll need much more data from suppliers of those genes, and suppliers of technology. But I hope that in the coming years we have some solutions like that, because this technology, democratization of information and intelligence and information, that is creating such a dual use technology, such a complex security risks that are coming our way. So I hope that you consider, doing, I tell this to everyone, who is really good in research and developing algorithms like you are. So I urge everyone that you focus on something like that, because in the coming years, we will face these complex challenges. But having said that, in this imminent healthcare transformation and revolution, it is going to create winners and losers. So who do you think will win and who do you think will lose here?
All technology creates winners and losers, in the sense that some people, but it might be more that some people just win more than others. So when you talk about the Industrial Revolution, and you might have said that they're winners are people who own factories, and the losers were the people who worked at the factories. But if you zoom out 100 years later, I think most people would argue that everybody won, that we now have the goods when we want them, and pharmaceuticals are produced at mass scale when we want them, and lifespans have increased. So when we talk about winners and losers, because we're humans, we always measure ourselves relative to someone else. And if we're not as good as someone else, then we're a loser. That's just the default for humans.
But the bigger difference, sorry to interrupt, but the bigger difference here, winner loser, is that we have established healthcare system where there is a supply chain, where people are making money, where people are making profits. And when you try to use technology to effectively predict all that, and to minimize the disease onset or minimize hospitalization, that is going to create a whole different kind of imbalance.
What do you mean? What would be the imbalance?
Imbalance in the sense that people who are profiting by more and more people becoming sick, they are going to lose from this, when we have effective way of preventing diseases, or we have effective way of identifying, where the high risk patients are. So that's what I see the imbalance is. So this is, healthcare is the second largest economy in our country. And, a lot of people are profiting because there are more and more people becoming, sick. And that is no other way to put it. So
got it. So you're saying that by losers, it will be people who treat sick people who then, by use of algorithms, are treated beforehand and are no longer go to them? Sure. In the short term, it's a loss. And in the long term, when their aunt gets that particular disease, then they're going to be a winner. So, this is, all it is to me on a longer scale isn't a loss. It's just a movement. They're going to flow from this sector to something else. So where do I think the turnover will be? Sure. I think great. Imagine that we say, look, if the losers in our society were the undertakers and the morticians and the people who dealt with people when they died because we solved all diseases, we'd still probably call that a win. So in some sense, yes, the people who will shift and will lose their job temporarily will be hopefully people that are supplying drugs that are only necessary once the disease has gotten out of hand. That would be probably the most immediate result. If you have predictive medicine, which makes a difference more immediately, then those who support advanced stage efforts will be losers. But the truth is, it won't probably have to be shifting very much, because once we cure one disease, another one will just pop up. So then maybe if it's a nurse who helps treat somebody with inflammatory bowel disease and that's their specialty, they'll probably just move into Alzheimer's, because we got nothing for that. There's no treatments anyways. You can predict it all you want. That's what I meant earlier when I said just because you have a model that's predictive doesn't mean it's useful. You can't do anything about it. So I can predict you're going to get Alzheimer's based on these risk factors, but it doesn't matter in preventing it. So the lesson in humanity is once you solve one thing, we just die from something else.
Absolutely. And let's hope that this imminent technology transformation and revolution that we are seeing, that it's not causing, or it's not facing complex challenges because of the people who are profiting today from the current healthcare system. And let's hope that, we are able to move past that, because there is going to be opportunity for everyone. But we want to make sure that we prevent human suffering and we are able to make healthcare more cost effective and timely and efficient. But having said that, what would you like to tell our global viewers and listeners, and to those young minds who are trying to figure out a difference by solving complex problems facing the nation, just like you are, how you are doing, how you are trying to solve the complex problem of disease diagnosis in a timely manner based on the insurance data. So how should they go forward? There are brilliant, people. There is a talent everywhere across nations. So what would you tell them? How should they move forward, and where they should put their more efforts?
I don't know if I know anything more than anyone else out there. I would just say I got here because I followed stuff that happened to be interesting to me. So I followed my interests and I just did that. So I liked machine learning, so I did it. I didn't do it with any intention to change the world. I just didn't. I did it because I thought, for me, maybe the advice is be honest with what really drives you. And so for me, if I was honest, I'm not out there to completely change the world and revolutionize human suffering. If I was, I would probably be doing, there's far more active things I can do to prevent human suffering than do machine learning on a potential thing that might work in 5 to 10 years. Instead, I found out that it was something that interests me, and I like the idea of an efficient system that does help people. So while I don't necessarily go out there and do hands on the ground, I'm like, oh, there's something we can fix that it's just a mathematical change that makes the world more efficient and makes, exploits the information that we have better. So I got into AI on healthcare data. And I would say that's a general viewpoint for deciding what you want to do. Be honest with what you want and do that. Don't try and pretend that I'm not Mother Teresa. I'm just not. It's not what I do. And I used to be bothered by that. And now I'm not. My contribution is whatever it ends up being. And it wouldn't be as good if I didn't follow what I was interested in. And then number two, more specifically about this field, I'm in the middle of Silicon Valley, and everything's being digitized. Everything's going from analog to digital and then networked and then machine learned. And so I think it's a huge field. I think there's a lot. We can't find enough people that are doing good machine learning out here and do statistics and know what it means, not just plug and play sklearn kits on Python. So understanding what you're actually doing, I think, is really valuable, and especially in the healthcare space, because if there's one thing that's true now that I think will continue is that people want to live now that we've solved all these things, we've solved so many things about, I mean, when's the last time we've had a really huge war? It's been 70 years. So the big scale things I think are under control. And now we're really looking at like, okay, the differences you can make, a lot of that can be done in healthcare and health and life, mental health, physical health. Getting it out there in a way that's useful and predictive is a big field. The AI and healthcare group at Stanford is a big one, and we do a lot of different events that I think people I get LinkedIn, people are hitting me up for like jobs and ideas about this all the time because this is the new revolution that hasn't been digitized yet. Getting doctor's notes and patient care and records and things into a wieldable format is on the targets of venture capital funds.
Very true. Very true. No, excellent advice. And be honest with what you want. That is an excellent advice you are giving to all our global viewers and listeners, and especially those young minds who are trying to make a difference. So thank you so much, Dr. Vaughn, for participating in Risk Roundup today. We appreciate your thoughtful insight on explaining the importance of machine learning techniques for reducing hospital admissions and readmissions, and our global viewers and listeners will benefit tremendously from the understanding you provided on the state of machine learning on insurance data to predict hospitalization. So even if a single individual or entity can understand the power of machine learning for predictive analytics to redefine and redesign healthcare based on the understanding they receive from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Great to be here. Thanks very much. Good luck.
Wonderful. Thank you so much. So while we are still at the beginning of machine learning journey, the ongoing research opens many new avenues for advanced predictive analytics that will bring healthcare the power for proactive disease diagnosis, reducing hospital admissions and readmissions in the years to come. This will not only improve the quality of human lives, but will also likely make healthcare cost-effective, timely, and proactive. Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts fit into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup webcast or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.